This is Mel Holmes Math 222, part 2 of the same section, 2.2. So again, the square root function, f of x equals square root of x. I plugged in 0, 1, 4, 9, 16 because they have nice square roots, 0, 1, 2, 3, 4. This is what the graph looks like. Then we have the greatest integer function. It can be written either this way or this way. I actually like it this way, it's easier to type. So it's sort of like brackets within the x right here. And the way the greatest integer function works is that f of x is the same as x if x is an integer. So integers are 0, plus or minus 1, plus or minus 2, plus or minus 3. If you plug in any of those numbers, you get the number back. But if x is not an integer, which means it has a fraction or a decimal part, you will always round down, not round off, but you always round down to the nearest integer. So some examples, the greatest integer function of integers themselves are the numbers themselves. So the greatest integer function of 3 is 3. Greatest integer function of negative 4 is negative 4. Now, if you have any decimal or fraction part, you always go down. So the greatest integer function of 3.8, you always go down to 3. You don't round off, you go down. Greatest integer function on negative 2.7, going down would be negative 3. Greatest integer function of 5 and 99 100ths, it would not be 6, you always go down, so that would still be 5. Greatest integer function of negative pi would be negative 4. Alright, and then let's see, to graph 2.2, number 1, f of x equals absolute value of x minus 4. You take the original v-shaped absolute value function, replacing it by x minus 4 moves 4 units to the right. And then over here, if you have f of x equals absolute value of x plus 2 minus 2, you take your basic v-shape, vertex at the origin, and this means 2 to the left and 2 down. So if I go 2 left and 2 down, 0, 0 becomes negative 2, negative 2. So that becomes the graph of the function of absolute value of x plus 2 minus 2. Alright, so this was also section 2.2.